Okay, folks, in this tutorial, I want to show you how to use the measure inertia icon in order to calculate the mass moment of inertia of a three-dimensional section. Now, by three-dimensional section, what I mean is, for example, surfaces which have masses, or three-dimensional objects, solid object, which have density and therefore masses. Okay. Now, uh, I have already created a tutorial where mass is not an issue. So therefore, although we still use this toolbar or the dialog box, mass inertia, measure inertia, but in a sense, we're finding the moment of area, second moment of area, which is a misnomer. You cannot call it mass moment of inertia. But this tutorial deals with actually mass moment of inertia. Okay. So let me remind you, in Catia V5, there is this toolbar which is called measure, and on the very right hand side of it, there is a weight here, and this is where you measure inertia. There are two tabs here. There are two tabs. This one is 2D that already did the video for it, and the other one is 3D that I'm going to be doing it right now. Now remember, uh, in a sense, this 2D should not be in a dialog box which actually says measure inertia, because you're not actually calculating the inertia of that surface to this section, but you're finding the second moment of area. However, this tutorial is dealing with actually a 3D object. Okay. First thing that we do, we make sure that our units are properly set. So if you go to Tools Options and on the Parameters and Measures and you search for inertia, you're going to get it right here. This is not what I need in the present tutorial. What I need is the next line below, which is actually mass moment of inertia as a unit of kilogram millimeter squared. Okay. Now, what I'm going to do is in this particular tutorial, I'm going to change this thing to kilogram meter square, and you'll see why. Anyways, let's move on. So that's really what we're going to be doing in this tutorial. Now you can customize and show different things. So if you click, for example, on don't worry about these numbers because this is just for sake of illustration. So if you click on the customize, it tells you what is it that you actually want to be displayed and you want to control. Okay. So the example that I'm going to do is this problem, okay? And the dimensions are given, and you're told that let's assume that the thickness is very small, so we don't model the thickness, but we are assuming that it has a mass density of 70 kilogram per square meter. Square meter. Remember, usually the density is kilogram per meter cube, but this is because we are assuming that the thickness is small, we're giving it the value in terms of 70 kilogram per square meter. Now, notice that this is coming from Miriam and Craig's book, and it's an example, and it's worked out, and I should be getting these numbers. And because the units here are in kilogram meters squared, I'm going to change my unit to that particular to reflect that. So let's go here. So tools options, and under sorted out or filtered out in alphabetical order, and let's find the inertia right here. Now I don't want this because this is for moment of area. This is what I want, and right now it's kilogram square millimeter. I'm going to change that kilogram per square meter. So we say okay. Now, on purpose, on purpose, I'm going to draw that geometry. I'm going to draw that geometry in a very weird way. So on the horizontal plane, I will sketch. And please note that I'm doing this thing on purpose. You may decide to do it differently, and I'll explain to you why is it that I'm doing it like that. So I'm going to draw a line like this, and this line that you see here essentially is going to be that line here. All right. But I'm not on purpose. I'm not doing it along the global what is that? The global y and x direction. I'm not going to do it like that. So on purpose, I'm going to do it as a slanted line, and let's dimension this thing. And this value, I believe, is 125 millimeter. So let me change this thing 125. Say okay, good. And then exit, and I'm going to pad it up by, not pad it up, but as a surface, I'm going to pad it up, extrude it by 100 millimeters. So let's go to extrude, get a surface, but this is part design. So in order to do that, I'm going to go to generative shape design, because I'm going to be creating a surface. All right. And I'm going to extrude this thing up by a 100 millimeter. Okay, so let's do that. Extrude is right here, this thing, 100 millimeter, there. So what I've created here for you is actually this piece. Now I'm going to draw this other line and then extrude it. So in that same plane, I will sketch a line that's perpendicular to that. We'll clean it up in a minute. So I want this thing, control that, to be coincident. And I want the angle between these two to be 90 degrees. 90 degrees. And say okay. Exit. And then pad this up by 150 millimeters. Oh, I think that length, this had to be actually 75 millimeter. I forgot about that. Let me dimension this too. 75 millimeter. 75. Exit. And then pad it up by 150 millimeter. Not padded, extruded. That's what we're doing with this, with the surface here. 175, 150, 150. There. So what you see there is actually, unless I made a mistake, is actually this shape. Okay. Now, the reason I did it in this weird way is I want to show you that sometimes you may not have a control over where these things are drawn for you. I mean, it looks like here you're saying that these things lie where X, Y, Z are aligned like that, but I mean, you have to create your own X, Y, Z. So this is why I'm going to create an axis system right here. See that axis system? It says, where is the origin of it? Where the origin of it is that corner point. And I want to line it up so that this will be Z, it's already good, and this will be my Y. So for Y, I'm going to select this. Notice that it rotated it so that Y is going to the right, Z is going up, X is going perpendicular. This is why I actually created this in a very weird way. I could have done it in the original global XYZ, but as I said, sometimes you don't have a control over that. This information is sent to you, and maybe you have to do it yourself. Now, here's the situation. Let me remind you where we have to go. We need to go to the measure tool. So there is the measure toolbar right there. There is the inertia. Now, this is 2D. I'm not dealing with 2D, 3D, right there. And it's already checked. This tab is checked. You select the part body, and this thing pops up. Now, cancel that. Let me try it again. Sorry. Select the part body. There, this thing pops up. Now, first of all, notice that because I have surfaces here, it says surface mass density is 10. Default is 10. So out of 10, I'm going to change this thing to 70. That's what it was. 70. So this matches the information that's given to me, 70 kilogram per meter square. All right. Now, notice that as soon as I click somewhere down here, these numbers will change because whatever you had here was based on 10, okay? But I don't want 10, I want 70. Now, the other thing is that this information here, this these numbers, see that IOX, etc., are given in terms of the mass center, which is right here. I don't want that. I want this information to be calculated, these inertia properties, mass inertia properties, to be calculated according to the axis system here. So here's what you're going to do. So first thing is click on the customize. See that there's a customize here. You click on it and make sure everything is selected. Everything is selected. Yeah, inertia there. You don't need everything, but just to be on the safe side, I selected everything for you. Notice that these tabs are now active now. Now, what we have to do, we have to select the axis system. You click on the axis system, you check this box, select this axis system, and go and select the axis system either from the screen or from the tree. Notice that it did change. The only problem is that and the only problem, actually, it's I don't want to say it's a problem. It's just that when this is all you do, it's going to use that access system here and calculate these things, these numbers with respect to the, assuming that the access system is located at that position, okay, at that position, and it is actually at that position. Uh, anyway, just be aware of the fact that because my access system actually aligned with these, what I wanted, I don't have to change a different point because I know that I want to calculate it with respect to this point. And this point is the center of the access system. Okay. Now, I'm going to compare these numbers with what we had, uh, in the slide. So let's start with IOX. This is mass moment of inertia with respect to x-axis. 0.026. Let me go here. 0.026. Now let's check IOY. 0.010. So we go here. IOY 0.010. Last one, 0.018. See that? 0.018. You go here, 0.018. Now let's check the product of inertia. Let's start with the very bottom one, 0.010, IYZ. IYZ is right here, 0.010. Okay. Next one, IXZ, 0.002. 0.002. And last one, oops, and last one, IXY 0.0369, which if rounded is going to be 0.004, 0.004. And here is your 0.004. Now, notice that there are minuses here because the convention in Catia is that these product of inertia, either you have the minus sign built in, or this in Craig's book, what we have here is actually IXY. If you look at the formula for example, IXY, if you look at the IXY right here, if you look at Craig's book, it's equal to negative, is equal to negative of integral of xy dA. Not dA, dm. Okay. The moral of the story is that don't let these negative signs in Catia bother you. These are not wrong. It's just that Catia's convention, when they wrote the code, they already put the negative signs in it. Whereas in Craig's, Miriam and Craig, later on you have to take these things and put a minus sign in front of them. All right. So that's pretty much it. Okay. Very good. Incidentally, if you want to create the center of create the geometry at the center of mass, you can go here and say, okay, create the center of gravity, and it's going to put an X here, right there. You can see that. And unfortunately, if you say axis system, create the axis system, it will not give you this axis system. It gives you the axis system associated with principal direction. Not that it's wrong, it's just that uh, these numbers that you see here are based on this axis system sitting at that location. Pretty much it. I will do a counterpart of this video tutorial for the version of Catia that's in 3D experience, and things are looking different. Bearing inside of 3D experience is actually the Catia program, but it's a night and day because the interfaces are different, and the toolbars are different, icons different, etc. But I'll do a tutorial on this exact same problem using the 3D experience that's released 2025X. All right, folks, good luck.